everybody, this is Tiziano and I'm here from the AutoPilot booth. I'm talking with ISRP Aero and actually I'm talking with MichaelduBreuil. And as you can see in front of me, I have one of their products, so I'm gonna let Michael actually talk and explain everything about it. Michael.
Sure, so this is a quad plane. It's designed for doing surveying and mapping. So it'll fly for 2 hours for the payload. It's designed to use a high-performance GPS, so we do PPK. So you can fly around afterwards, pull the SD cards out, post-process the data, and that gives you highly accurate data for doing photogrammetry. And you use that photogrammetry to derive survey products, planimetrics, orthomosaics, whatever your end client needs. So it's designed to do that, and it's designed to do that very autonomously. So it takes off automatically, it'll transition to forward flight, land vertically. You don't have to know how to do a hand launch. And it's designed to be very simple for the user.
Now, PPK, what does it stand for? What's the difference between a standard GPS and a PPK GPS?
So PPK is post-processed kinematics. It's very similar to what a lot of people know as RTK, which is real-time kinematics. So normal GPS, we just receive satellite data and we calculate a position.
Yes.
That's typically about 2.5 meters accuracy on L1 only. The next step up is you can get a correction from the satellite service, and that can get you down to a little bit better. Then you can move to something like this GPS, which is dual band, so you receive on different frequencies, and that'll be more accurate again. So without any correction data, this GPS is good to about 0.6 meters horizontally.
0.6 meters?
And 0.8 vertically.
Wow.
Versus 2.5 horizontal and 5 vertical on a normal GPS. The next main refinement you tend to see people do is real-time kinematics. So with the GPS on the aircraft, you have a GPS on the ground.
Yes.
The GPS on the ground has to know where it is, but once you know where it is, you can forward correction data from there to the aircraft and get the aircraft down to centimeter accuracy.
Centimeter accuracy?
Yep.
Wow.
Post-process?
In real time, so you can actually fly on the spot?
Yep.
Great.
Post-process kinematics does the same kind of math that real-time kinematics does, but instead of needing to upload data from the ground station all the time to it, we log it on the ground, we log it on the aircraft, and afterwards we post-process. We bring the two together. We do LSJ math in the forward direction, which is what RTK does. We also do the reverse direction,
Yes.
and then we combine the two results to get a better position. The other main advantages you see out of PPK is that you don't have any data holes. Both sides logged at full rates. If you had a bad radio link or you lost connection for a moment, you don't have any missing correction data.
Good.
With RTK, your accuracy estimate gets a little worse when you do that every time. It's not super quick, so as long as you don't have, an outage of more than like 5 seconds on that correction data, you're not really going to notice it generally. But those things do tend to happen when covering large areas.
Yes, I get it.
PPK, you can also sometimes pull on a variety of correction networks. So sometimes you don't have to have your own base. You could go use one that's provided by the state. If it's close enough to you, you can use that instead. So using that and then using the software that makes it very easy for you to work with, you get these high accuracy results without having to have surveyed in the point in advance.
In order to have a product that is that performant, you chose to use AutoPilot.
Yeah.
Why?
So AutoPilot gives us basically what we need to do the job. It gives us a lot of tools. It does what we need it to do. Now there are places where we want to come in, and that's how I got involved with AutoPilot, where we said, okay, we want a little bit better performance out of this, or we want to change this behavior a little bit.
Yeah, exactly. I mean, you're also involved in the development of the software.
Yeah, so I'm the GPS, battery, and one of the plane developers as well. So I'm deeply involved in those parts, and that was because I needed a little bit of a tweak, or we need to improve how we handled something.
Okay, so instead of going and asking to do some modification, you actually stepped in.
Yeah, now, the modification needs to be accepted, and all of the things that we fly in this vehicle are in the AutoPilot tree.
Yeah,
so we've pushed everything back, so everybody gets to benefit from it, and you get feedback from the rest of the community where it's like, oh, what about this special case? Like, oh, right, we need to handle that correctly. But because we've done that, this has been improving the quality for everybody else, and then when other developers who are improving their products bring that back in, AutoPilot just as a platform keeps getting better and better. So you benefit from things that we do, and then you benefit from things that other companies present as well. And that's how you get to the spot where the vehicle does what we need to do out of the box.
That's actually the benefit of having an open source project, an open source community where you have voices from all over the world that can tell you, hey, your idea is horrible, or it won't work, or your idea is great and it will work because of that or that. So you're going to collect a lot of experience, and then we're going to push them all into one common software. And
yeah, it's not normally your idea is horrible necessarily. It tends to be that, hey, you've missed a reason why that's not the best way.
Exactly.
And let's try and get towards what we think is the best way. you're not always stuck on, hey, this must be the best way right now. You know, incremental improvement is the name of the game. That's what we do. Everything just gets a little bit better.
Of course, but that's the thing. You know, you rather than asking for doing any modification, also you guys, if you see that you need any improvement, you have to step in the community and start talking, asking, debating about that, and if you can, give it help and give your support to the community. If you know how to code, you just jump in, don't be shy, and try and do your best. I mean, the worst that can happen, it would be rejected or not brought to the master, but try
but
that.
Even then, we work with people to get those things improved and get them in. And one of the other ones that comes really valuable is outside of even just making the changes, the ability to go in and go, I don't know why I did this. If you can start to understand why I did that, you can look at the code. Because we've dealt with some systems in the past where it's, why did the vehicle just do that?
Yeah.
And the answer is, I don't know. And I need to go find a support contract engineer from the company to tell me that.
Yeah.
The ability for us to go, okay, why did that happen? Or, you know, a user sent us back a log and go, okay, we can go figure out why this happened.
Oh, yeah, no, this is so valuable. The big value is really the reachability of the community. Once you have a trouble, a problem, you can actually either upload the telemetry log and have someone, you know, giving you the answer, giving you their opinion, what was going on with your platform. And this is really great. I use it myself for a long time. And also, it's been, what is invaluable is the fact that whenever I saw something weird or I didn't understand, I could read the source code, because, you know, reading the source code, it gives you all the answer. What's going on here? Why this happen? You go in the source code and you figure it out. And the source code is written, has a pretty.
It's getting better.
It's getting better.
But it's one of those things where, again, we want to get better. So
exactly.
You start from where you are and you just improve it as you go.
Exactly. For example, if you want to give support, one good way is giving support through the documentation.
Yep.
If you don't know how to code, you can start documenting the code. Helping people to document.
The wiki probably more so in the code, because it's hard to document code if you don't know how to code.
Yeah.
But the documenting behaviors on the wiki, addressing confusion on how to set things up particularly. You know, if you've got a vehicle that's working and you want to get involved on how to help more, helping others with both on discuss or here's how to set up a vehicle, or addressing deficiencies on those parts of the documentation site is a great way to get involved.
Yes.
And that really pays back to the rest of the community and helps bring in others further.
Oh, I totally agree about that. Now, tell me something specific about your machine here, your vehicle.
It's really focused on that mapping application at the moment. Flying for 2 hours on an all-electric vehicle.
2 hours?
Yep. With payload.
Do you use a lithium polymer, lithium-ion battery?
We use both the lithium-ion and the lithium polymer. So there's a battery pack for the forward propulsion and avionics, and there's a dedicated pack for the vertical takeoff.
No kidding.
And that's done for optimization around the battery.
Yes.
It's very hard to optimize your vertical lift components against the voltage sag on the ion pack. So this lets us optimize our forward propulsion, and then we can optimize the vertical propulsion independently and arrive at a much better solution than just trying to make everything work off of a single pack. And then the other step with that is then breaking the batteries down into 100 watt-hour packs for transport and shipping reasons. I don't know if you've had to deal with it before, but trying to ship large battery packs to people is a very large problem, as well as taking it on the plane. So a lot of the system outside of the capability is just designed around making it easy for users to use. So everything on the system breaks apart. It all breaks down to a single transport case, and making sure that people don't have to mess with connectors, and then minimizing error on that is the rest of the focus.
Oh, that's great. So where can we find all the information about this product and your company?
You can find it on our website, which is just srp.aero, and that is a real domain name, so if you type in .aero at the end, I promise you'll get there.
Okay. Thank you everybody for watching, and I'll see you next time.